In our next section, we're now going to take a look at the configuration for failover, starting with failover in single context mode, routed firewall, and then as we progress to multi-context mode and transparent mode, we will revisit this and then look at the failover variations for those as well. Now, as I mentioned previously, the first requirement of failover is to make sure that you have a matched pair of the hardware and software. So assuming that that is not a problem, the next step is we need to make sure that there are identical configurations in the infrastructure for the primary device and the secondary device. Now here we see in our particular diagram that we are going to be dealing with, we have the same design as before, where we're going to have three different interfaces. We're going to have the inside that goes to the test PC. We have the DMZ that goes to router 1, and then we have the outside that goes to router 2. Now we saw that when we were doing basic initialization, there were some other steps on the back end that we needed to do, like configure the trunk links from the switches to these ports to make sure we're actually forwarding VLANs 115 and 215, and that this link here has the correct access VLAN assignment onto it. Now when we're doing this with failover, we need to now make sure that we're essentially replicating that config onto the other device as well. So this means that whatever configuration we have on this interface of ASA 1 has to be the identical configuration of this interface on ASA 2. Or if we're doing the trunking here on port 13, we need to make sure that we're doing the trunking here on port 15 as well. And again, within the scope of the lab exam, they're probably not going to tell you this. It's just an implicit requirement that the infrastructure has to be set up properly in order for these upper layer applications to work. So if they don't specify what VLAN numbers you need to use, there has to be something configured on there in order for the ASAs to communicate with each other. So in our particular case, we're going to be using this interface E02 on both of them as the failover link. This means that these two ports here, they need to be in the same VLAN, and we also want to configure these as port fast ports or edge ports from a spanning tree point of view, because we want to make sure that if there's a flap of the link, that there is not additional layer 2 convergence on the switch ports that is going to affect the failover convergence on the ASAs. Because remember, the ASAs are going to be polling each other here with some sort of timers, and we don't want the underlying layer 2 convergence to cause an issue in the failover convergence. So this is where we need to start first, is with the layer 2 configuration. So let's look at switch 1 here, and we need to basically take whatever configuration is on ports 12 and 13 and then just replicate this down to interfaces 14 and 15 respectively. Okay, so on switch 1, let's show run interface F1012 and 1013. So right now we're not using the management port, but this is the important config. This is the trunking config that is for the DMZ and for the outside interface. So I need to make sure that this is going to be replicated onto port 15. And no shutdown. Okay, the same is true on switch 2. So interface 12, whatever that config is, needs to be the same as 14. 13 needs to be the same as 15. So we don't want to waste time troubleshooting something related to the failover config when it's really just an underlying layer 2, layer 1 infrastructure problem. So on switch 2, let's show run for fast Ethernet 1012. And this needs to be the identical config of 1014. Then if we look at interfaces 13 and 15, that's what we're going to use for the failover. So show run interface F1013 and 15. We need these two ports to be in the same VLAN. And again, we would probably want to run them as edge ports for spanning tree. So let's say we have a new VLAN. Let's say VLAN anything, 999. This is going to be for, we'll say the name is ASA failover. On the interface range F1013 and F1015, These are switch ports. The switch port access VLAN is 999. And spanning tree port vest is on. And no shutdown. So pretty straightforward here, but again, it's just one of those minor details that if you were to overlook, then of course none of the upper layer protocols are going to work. So always make sure that the basic layer 1, layer 2 is working before you go on to any of the actual application configuration. Okay, also on the ASA, let's make sure that its links are up. So let's go to all the links, E00, so we say no shut, E01, and E02. Same thing on the first ASA. So if we show interface IP brief, E02, no shutdown. Okay, let's look at the show interface IP brief. Again, I just want to make sure that the links are up, which they are. Okay, so let's take a look now at the documentation and figure out what's the step-by-step process that we actually need to do in order to get the failover to work. So again, this is under the 8486 documentation, and then we're going down to configuring high availability. And this is going to be active standby failover because we're running in single context mode right now, not multi-context mode. And as we saw before, the way that we can check this is the show mode and the show firewall. So we are in single context routed mode. Okay, what I want to see basically is just what is the task flow for configuring this. So what's the step-by-step list of exactly what we need to do and what's the order that we need to do it in. So you could look at their example and basically paste it in there, but if it doesn't apply in the exact correct order, we're going to have a problem. So we're basically going to follow this step by step. Okay, first it says that we need to configure the primary unit. And as we build this, I'm going to list these commands here in my text editor so we can look at the final result afterwards. Okay, so first on the primary unit, it says that follow the steps in this section to configure the primary unit in a LAN-based active standby failover configuration. And as I mentioned, what does LAN-based mean? This is stateless failover. So we need to think about, are we going to run stateful failover as well? If so, there's going to be an additional step. Okay, it says don't configure an IP address on the interface for the stateful failover link if you're going to use a dedicated stateful failover interface. Okay, that's what we're going to do here. We're going to do the stateless LAN and the stateful link failover together. Okay, so first off on ASA 1, we're going to say that this is the primary unit. What's the interface that we're going to use for failover? It says the interface name and then the interface ID. So you have to be careful with this and make sure you look at the context-sensitive help, because some of the commands, they look for the name that you're giving it. Like in this case, they're saying FO link, and then in some commands, it's looking for the physical interface, like gig01. And it's not always self-explanatory which is which. So here we're going to say that the interface name is our failover link, and the interface ID in our case is E02. Okay, then what's the address that we're going to use on the failover link? Okay, here the IF name, this is going to be the name if that we gave it. So now it's referencing failover link. And you can see you could also do this for IPv6 if you want to do v6 failover. So the interface name is going to be the failover link. IP address, this is arbitrary because it's only locally significant between them. So let's say 169.254.0.15, and the mask is going to be 255.255.255.0. And then what's the standby address? Let's say the remote device is, and standby is actually the keyword there. So they are 16. Okay, so ASA 1 is 15, ASA 2 is 16. Then, of course, we need to make sure the interface is shut down. Okay, we already did this. This is now optionally what is going to be the stateful failover link. Here it's specifying the name and then the physical link. In our case, if we're doing it with the same one, basically we just need to copy this command and say the failover link is called, in our case, failover link, and then it's E02. So we're doing both of them on the same link. Again, from a design point of view, normally you would not want to do this because this config here is what's generating all that control plane synchronization. This one here is just for polling between the devices. You want to make sure that the state replication doesn't get in the way of the polling. Then what's the failover interface IP address? Okay, we already did that here. So you don't have to do it twice. And then turn failover on. Okay, this is actually going to be our very last step. We don't want to turn failover on until we make sure that everything is properly prepped. Okay, so this is going to be for ASA 1. Now for ASA 2, the secondary unit, it's basically going to be the same, identical config, with the exception that it should say here, we are the secondary unit. So we could take this and then say that they are the secondary. And that's essentially it. Now, of course, we can configure the other minor features, like change the poll time and stuff like that. But what I would recommend to do is to get the minimum functional configuration. Then if you want to make changes afterwards, go ahead and do that stuff. But I want to make sure that the configuration replicates from the active to the standby first, that I can fail over back and forth manually. Then once that's done, I'm going to do any type of modification, like if I want to pull the interfaces. Okay, so our next step now is I want to make sure to save the config. Because if I do this in the wrong order and I copy this config to the ASA 1, it's basically going to override everything. Okay, that is what is the problem with the order of operations. Okay, you can just paste their example in, and if you don't have any other configuration, that's fine, because you don't really care if it deletes your blank config, deletes what was already a blank config. Okay, so this is going to be our primary. Failover link interface, specify the, no, that should have said, there we go. Show run failover. So this is the stateless failover config, this is the stateful failover config. Okay, so again, these can be the same one, but normally you would want them not to be. So same configuration on the other side, except the difference is they are secondary, not primary. Okay, next we're going to turn failover on the primary box first. Then on the secondary box. Okay, if this is going to work, what we should see is that we detected the active mate. This means that the layer 2 keep alive over the stateless failover link is working. So this means that on Ethernet 02, there is communication between the two boxes. So if we did not correctly configure the LAN switches, ASA 2 would not have been able to find ASA 1, and it would have promoted itself from standby to active. So we would essentially have a dual active case where ASA 1 is forwarding and ASA 2 is forwarding, but there's a disconnect at the underlying layer 2 infrastructure level. Okay, end configuration replication from the mate. This is what we want to see on the standby one. On the primary, we should see that it's sending the configuration to the mate or to the remote device. Okay, we can see now both of them are going to have identical configurations, even down to the host name. So here, if we look at show run, all the other configuration that we already had was replicated over. So the sub interfaces with their IP addresses, etc., everything is copied on a one-to-one basis. Really, the only thing that is different between these two boxes from a configuration point of view is going to be, if we show run failover, just this command. Essentially, everything should be the same except for this. Okay, next let's look at the show failover. It says this host is secondary and it is standby. The other host is primary and it's the one doing the actual forwarding. Okay, now additionally, notice here it says that the inside link is unknown and the other interfaces are not monitored. This means that they're not completely converged in the process. We need to make sure that this says that it either says up or OK. Basically that the polling between them is fine. Okay, then it's going to stay for the stateful failover link. How many TCP connections do I have? How many UDP connections do I have? Okay, also for the VPNs, am I replicating my IPsec security associations? Now, if we were to send traffic through the ASA, so let's say we go to the test PC and we do a telnet to router 2. Telnet 136.1.215.2. If the stateful failover is working, we should be able to look at the primary box, of course, and show connections. And on the secondary box, should have the identical entry. This is what is making it the stateful failover. That when the connection occurs on the primary device, it's automatically copied down to the secondary device. Now, the next thing we probably want to do is to change the prompt for the parser. Because when we're looking at the two console connections to both of the boxes, they both have identical host names that are called ASA1. So if I SSH into the box, I should land on the active one, and it's going to have the same host name as the secondary one. But the problem is I don't necessarily know, without having to look at the show failover, which box am I actually on right now? Am I on the primary one or the secondary one? Am I on the active one or the standby one? Now you will see that when you go into global config, if we say config T on the primary box, that's as normal. It says, we go to global config. If we do the same thing on the standby box, it should give us a warning message here. It says don't make changes because the config is not replicated from the standby to the active box. Now it is replicated from active to standby. It says if you make a change, the configuration is no longer going to be synchronized and there's going to be a problem in failover. The issue is, though, what if I was in global config and I forgot about that and I come back to the box later? I really have no way to tell now without looking at the show failover that this host is actually the standby one, and I should not be in global config here. Because again, any change that I make is not going to get replicated down to the active box. There is a simple fix for this, though. On the active box, we want to change the prompt so that it shows the host name, but it also says what is my context and what is my state. Okay, we could say the priority if we want to as well. And let's say write memory all. Or actually write standby. Okay, write mem all, that's going to be for when we're in multi-context mode. This here is going to do an explicit push of the config to the remote box. If we look at the remote box now, we can see it's ASA 1, but it's the standby box. It's the secondary one. The other one is active, and it is primary. So now when we connect to the console, we don't have to worry about accidentally making the changes on the secondary one, because we can see in the host name, it is ASA 1, but in the ASA 1 pair, are we talking about the active box or are we talking about the standby box? Now we'll see when we get to multi-context mode active failover, this becomes even more complicated, because I can say that ASA 1 is active for context A, but ASA 2 is active for context B, which means that when I make changes for A, I need to make sure to make it on ASA 1. And when I make changes for context B, I need to make sure to make it on ASA 2. So it can get confusing where you need to make the changes. That's why in general you want to change the prompt so that it tells you, am I currently the active forwarder or the standby forwarder for this individual context? Okay, where in this case we're running in single context mode, so it's active standby, it's not active. Okay, let's look at the show failover again and see if the monitor interface is up. Okay, here it says that the interface inside is still unknown, it's waiting. The reason why, if we look at the show run interface inside, or actually E00, I didn't configure the secondary address that I can use for the monitoring. So when we look at the show run failover, these, let's see, this one, basically everything except this, that would be the minimum config. So it's basically only 4 commands that you need. So is this the primary or secondary unit? What's the link that we're going to poll each other on? What's the IP address of the link? Then turn failover on. Okay, this is saying this is where we're doing the state replication. This is for a stateful failover. But if we now want to monitor the other interfaces like the inside, we need to put IP addresses on them, just like we have for the failover link. So if we show run for interface E01.115, we would need the standby addresses configured as well. Now again, remember, when you actually make these changes, you're always making the changes on the active box. So even though the secondary one owns the standby address, from a configuration point of view, the changes for management are made on the active forwarder. This is the reason, again, that you want to change the prompt. So you can see, am I active or standby? Okay, so let's go to these interfaces here. Let's say E00. On E00, this is the address, but the standby box is going to have the address .16. Okay, same thing on E01.115. This is the primary, but the secondary is, or the standby is .16. So again, you don't necessarily have to do this. The only time that you need to configure these addresses on the data plane links is if you want to do the monitor link or monitor interface. Because the platforms, they're already polling each other over this failover monitoring interface. But the problem that you would want to avoid is, let's say that someone goes into the layer 2 switch and they make a change where on this particular port they say no VLAN 115. So someone accidentally edits the allowed list on the link and removes VLAN 115 from forwarding. Now, since the ASAs are polling each other over E02, they don't see that there's a problem there. But from an actual data plane forwarding point of view, when I go to send traffic out this interface, if the switch is not allowing VLAN 115, then it's not going to actually accept those packets in the data plane. This is the reason why you would want to configure the additional monitor interface, to make sure that there's not some sort of software or configuration failure that stops the box from forwarding that the failover cannot natively detect. Okay, if we go to the secondary and look at the show run output, we can see that these changes were already replicated. Okay, but you always want to make sure to save the config. When you save the config, it should be saving it on the primary, and then it's also going to push this down to the secondary. So the secondary, you can see it's saving its config also. Okay, now if we look at the show failover, we should see this link is now monitored. If we wanted to add those other ones, let's say monitor interface on the DMZ and on the outside. Show monitor interface. Okay, they're going to start to ping back and forth, and once they get the keep alives, these should change to, they should change from waiting to monitored, which they are. Okay, next let's see, can we actually get the failover to work? The first way I'm going to test this is to force the failover. Then once it works, we'll fail back, and then we'll test it from the actual data plane. So is the monitoring working as well? So let's say on ASA 2, from exec mode, we want to be the failover active box. So we're switching to active, so you can see the standby keyword there changed to active. The other one now switches to standby. Now that they've failed over, does the data plane still work? So can I go to my virtual machine, and is my connection to router 2 still working? Okay, which it is. So let's say that we do a ping here, and while we're doing the ping, we fail over between the two boxes. And let's see, is the VM actually going to lose reachability? So on ASA 1, let's say failover active. So the active forwarder is changing, but you can see there's no additional convergence time. Okay, now we could check, is the failover stateful? We could check this with a TCP connection. So telnet to router 2, do the failover, and see, does the telnet connection stay up, which it does. If this was a stateless failover, we would see that the connection would be lost and would have to be re-established. So we can see that if we go to the active device, let's say show run failover, and let's remove this command, which is the stateful failover. So we're not doing stateful failover anymore, just stateless. We can see the telnet session still open. If we fail back over, actually, I would have to, let's do this. Let's exit and then restart, because they had already previously synchronized that connection. So we'll telnet to router 2. Then fail over to the secondary. And now we can see the connection's lost. So this is really the main difference between the stateless and the stateful, is the TCP and UDP connection table along with the IPsec data copied over to the standby one. But again, remember, it has to do this on a per connection basis. So if you're doing them on the same link, polling the devices and doing the state replication could overwhelm the polling, and then the failover would occur on in like an error case. So normally, again, you want to do them on separate links, but for our purposes, for the lab, it's not a design issue, it's just basic functionality. Okay, there's a question here. If the monitoring link shows that the pings aren't making it, but the failover and LAN links are still up, would it fail over? Okay, that's what we're going to test next now that we're monitoring those inside and outside interfaces. So essentially here, there is an extra copy of all of these links on ASA2. So ASA2 has the inside, okay, we could say it's part of that segment. It's also part of this test PC segment, and it's part of the outside segment. So since we're monitoring, basically the boxes are pinging back and forth between each other on each of these links to do the monitoring. So what would now happen, let's say we go to our outside and we misconfigure the link that goes to ASA1. Even if this interface is up, are they still going to fail over? Well, it really depends what is the monitoring policy. So if the interface policy says that if any of the links fail, then fail over, then we should see it occur. But if we configure it as a higher percentage or a higher count, we might have to have more than one of them fail the monitoring situation before the devices actually fail over. But one is the default, so we should see that without making any changes, that's going to be the case that we run into. Okay, so let's say that ASA1 is going to be the active one. On ASA1, we'll say failover active. So we switch to active, they switch to standby. Okay, next let's go to the VM, and let's ping router 2. So this traffic is going to go to the outside, and let's keep that ping running. Okay, next we're going to go to that outside interface of ASA1, which is right here, and we're going to remove the VLAN, which in this case is VLAN 125. So we're going to remove this from the allowed list and see if they can detect that between each other. And while we're doing this, let's look at the ping. So on switch 1, this is going to be on port F1013, I want to say, which it is. So let's go to interface F1013 and say switch port trunk allowed VLAN remove 215. So we can see now that VLAN's not forwarding, so the traffic is dropping. If we look at ASA1, let's say show failover, and we're looking at the outside interface, which is right now being monitored. We can see now the active one says, I have to fail over because my outside interface failed. So this would be the ideal case that you want, because not only do you want to check that point-to-point link between them, you also want to check, is the data plane actually functional? Now, the easiest failover situation to detect is that if the failover link goes down, you know that the other box is gone. Like if it power cycles, then the link is going to go down and you know that the secondary needs to promote itself to the active. What is the more difficult situation to detect is this type of software failure, where either there's a configuration issue or there's, maybe there's a process crash on the primary box. You need to make sure that the secondary one detects that. And the case here is that for the sub-interfaces, it does not do that automatically. So this is where we need to go and configure the secondary addresses, or the standby addresses, I should say, and then also the additional monitor interface policy. So if we show run monitor, that we're monitoring, monitor interface inside is the default, but we want to monitor the DMZ and the outside. So again, when we look at the show run failover, there's really not much that's involved with the configuration. It's more of an issue to make sure that the underlying layer 2 infrastructure is working properly first, that we do these steps in the correct order, and then test doing the failover in software, so manually fail it back and forth, and then do some sort of failure situation like shut the link down and see if the failover actually occurs. Okay, there's a question here. Do we know if both ASAs share the same MAC address so they can work as the failover? Yes, they do. And the way that we can see this is by looking at the IP destination. So let's look at router 2 and look at the show ARP. And let's do this. Let's say clear ARP. We see that there's two different addresses here. There's ASA 1 and there's ASA 2. So this is the primary, this is the secondary. Okay, let's go back to the switch and let's fix that failure situation I was doing. So switch port trunk allowed VLAN add 215. And we're going to say that the ASA 1 is the active. So failover active. And let's see, how could we check this? If we go to router 2, so let's look back at our diagram here. On router 2, I'm going to configure an inbound ACL on this interface here, gig 00, that I'm going to have it log input. Now remember, we talked about in regular iOS when we're logging ACLs, we have two options. You could say log or log input, where log input is going to tell you what was the incoming interface plus the layer 2 forwarder. So what was the MAC address of the device on the link that sent the packet? So on router 2, let's do this. Let's say access list 100 permit ICMP any log input, and access list 100 permit IP any. Do show access list 100. Okay, this is going to be applied on gig 00 inbound, so IP access group 100 in. Okay, we can see from 10.1.0.100, it says the source was 8917. If we look at the show ARP, 8917, this is the .15 address. Okay, let's also say this on router 2. IP access list, the log update threshold is every 1 packet. And actually, let me make this access list a little bit more specific so it cuts down on some of the output. Let's say here, no logging console. Do show run pipe section access list. Let's say IP access list extended 100, no sequence 1. I'm going to change this to say permit ICMP from the host 10.1.0.100. So just from the VM, and then log the input there. Show access list, and then logging console 7. Okay, so what we're looking at here is the MAC address. Why is it still logging the... So those must have been old hits that are still stuck in the buffer. Okay, so on ASA1 is the active device. We can see the VM is still sending the packets. We go to the switch and we cause the failure. So we remove VLAN 215. Okay, now the virtual machine should lose reachability. Once it detects this and failover occurs, if we go back to router 2, let's see what is the MAC address that the new packets come in from. Because it's going to have to switch from ASA 1 to ASA 2. So ASA 1 says I'm switching to standby. Okay, now the flow continues. And if we look at the ingress MAC address, it's 8917. Again, when we look at the show ARP, who was 8917? It's the primary address. So the idea behind this is that if you did the failover to a different MAC address, all of the other layer 3 devices on the segment would have to flush out the ARP cache. Now you could theoretically do it this way. You could have the ASA generate a gratuitous ARP in order to flush out the other devices' MAC addresses, but that's not the way that they did the implementation. What they did instead was just to say when the standby takes over the active role, have it assume the primary IP address and the primary MAC address. So from a management point of view, if we were to SSH into this .15 address, we're actually going to end up on ASA 2 because it's now the primary forwarder for that particular IP and MAC pair. So you can think of it kind of like how HSRP works, where it's a virtual address now, where whoever is the active forwarder, they are the one that is assuming that IP and MAC pair. Okay, there's a question here, what would occur if the same monitor interface on ASA 1 and 2, both interfaces fail due to a misconfiguration? So the question now is, well, what if I do that same misconfig on the other port? This, unfortunately, they're not going to be able to account for. So if there's a double failure, then forwarding is no longer going to work. So if we look at the show failover, let's do this. Let's say show failover include host or interface. On this host right now it says outside is normal. If we check on the other one, we should see that both of these go to actually, no, they're not going to both go to failed because it depends on the order of operations. So the secondary box wasn't able to detect the primary, so the secondary is promoting itself to the primary and it's saying, I'm not going to monitor that interface anymore. So yeah, it really depends on the order. But in any case, if there's a double failure, there's not anything that you can really do because there's only 2 devices in the failover pair. You cannot have an active forwarder and then 2 standbys. So it's not like HSRP where you could have 3 routers in the same group. It's a pair. It just has to be active standby. Okay, we'll see with the multiple context mode, what they call active-active failover is actually active standby failover on a per context basis. So you still only have 1 forwarder at a time, but it just depends on is this, are you the forwarder for context A or context B, but you wouldn't both be forwarders for A or both be forwarders for B at the same time. There's a question, can this behavior change if we enable the MAC address auto command? We are going to look at that when we look into multiple context mode. So when we do active-active failover and then we have the automatically derived MAC addresses, we'll see how is that going to affect what is the primary IP address, what is the primary MAC address, is it the physical interface one or is it the generated one? Okay, there's another question here. To configure failover, should the 2 ASAs have the same exact model, hardware, features, and licenses? Yes. So basically they have to be an identical matched pair. Now, I think there is an exception to this while you are upgrading the code, that if you're upgrading the secondary one and then you fail over, and then you upgrade the primary one, because you need to be able to do basically an in-service software upgrade. So there are cases where you can temporarily mismatch the code while you're doing the upgrade. And some other minor things don't need to match. Like the amount of flash doesn't really matter between the two of them, but you want to make sure that they're running the same code and that they have the same hardware and licenses. Okay, also for the ISSU, if you are doing this in production, you need to make sure to check the release notes, because it's not hitless for all upgrade paths. So if you go between minor sub-releases of the same major release, like for example like 8.4.1 to 8.4.2, that should be fine. But if you go from like 8.2 to 8.4, then that's not going to be hitless. But in general, they should be basically mirror images of each other, the failover boxes.